Arduino circuit, where the light sensor is plugged into analog input, A1 pin, and where our servo motor is plugged into the analog output, pin A8. So this can be applied sort of a simplified version of an architecture, and where it can detect the amount of light penetrating into the building, and the facade itself can rotate to permit more light in when it's dark inside. So here you see I can put my hand on and the servo motor will turn. And here in this tutorial we'll be also looking at the data in Firefly. So like previously, we used this parts available component to check which part there's, and here we have 3 and 7, and also using the open part to decide which one you want to open. And yeah, by using a toggle, and after that we'll grab the mega read and just attach the part back in, and also using the toggle to attach to the side. And we'll just open up this value tracker where it can visually display the different values in a graph format. And for our mega read, we'll attach the timer on and we'll change it to 1 millisecond. So after that, yep, here's the first data log method, and this one is buffer where you plug in data on at D, and for D it stands for the domain. So here we have 0 to 20. And so what is buffer? Buffer is actually, it inserts the new data at the beginning, and hence it shifts the previous one down the list. And the second one that we're showing is data log. And the difference is that data log actually put the newest data at the end, and it will just keep recording it like a logbook, and it will just keep on recording endlessly unless you set a limit. So the point of using a buffer is in here we'll show we'll just show it as a normal data plug into our final output, but then if we have buffer a second buffer data, it can generate a second bunch of output where it can be a bit slower or sort of lag behind in time. And now we'll just use the remap to change from the S from 0 to 1023, which is the analog input from Arduino. And for T, we'll change it to 0 to 108, since that is the rotation radius for the servo motor. And like shown previously, we use move to reduce the ambient noise. And we'll just use a geometry in Rhino to just display what we are doing physically onto in Rhino as well. So then for our final output, we'll just attach it to mega write, where the smoothed out data is plugged into the pin. Yep. In this case, we'll plug it into pin 8 and 9 because we want to use a dual motor servo. And yep, remember to right click at the D pin to change it to servo. And yep, here we have our complete the script. And let's just run it. We have to sort of click all the different toggles in sequence to make sure it doesn't fail, because there's a particular system of how you actually run Adreno modes. And yeah, for the data tracking, sometimes there's some problem with displaying with the input of data. So it might help if you change the data input period into a shorter one. And now we can see the rotation in Rhino. If there's different amount of light in this case. So if I put my hand on, it changed a bit more. And also here we're just testing out the smooth component. So the more number of value of data you put in to generate the average, the smoother the movement it is. So here with roughly around 30 is much better.